Okay. So on this first one, you have log base 6 of x. Number 5. So you're going to put the 6 here. Right arrow, x. And that's log base 6 of x. Now, for the people that don't have the alpha Windows button, you can type in log of x. Do the top one right here. You go straight across. Divided by log. And the log is right here. Of 6, which is the base. So it's log x divided by log 6. So both of these are the same graph, so I'm just going to graph them at the same time. So you can tell that it's really close. I'm going to press zoom 6 here. Zoom 6 gets me on a normal screen. Zoom 6. So you can tell it's pretty close to the x-axis here. Okay. Now, even though it looks like it stops, it does not stop. It goes all the way down. Your axis is definitely the 0. Now, 1/36 is so close to 0 that it's barely graphable. But when you want to punch this, we're going to press in second window. Now, where it says independent, we're going to go down here to ask. See where it says ask, and then we're going to press second graph. Now we can ask it. I only use the ask button if I have fractions that I have to find. So it's 1 divided by 36, and that's -2. And then you type in 1/6, and that is -1. And then you're going to type in 1, and that is 0. And then you're going to type in 6, and that is 1. Okay, so we're going to graph these. So 1/36 is really close to 0, really close. So that's right there. 1/6 is a little to the right of that, and that's at -1. Then you have 1, 0. Then you have 6, 1. And that's a curve, so you kind of come down this way. It's going to be curvy. Make sure it curves. And you follow that all the way down without hitting the x or the y-axis. So put your arrows on here. Your domain is whatever the vertical asymptote is, which is 0 to infinity. Your range is all real numbers. So you can either just write a fancy R and be done, or you can write -infinity to infinity. So that means low to forever, high forever. Your range is always low to high. Your domain is left to right. So for the next one, let's clear these out. You have log base 1. So you have log, so it's alpha window 5. We're going to put in a 1/5. And then you're going to type in an x. And you're going to graph. Okay, so let's look what the graph looks like. So because there's a 1/5, it means it's going to go down instead of up. So it's going to decrease this. So let's go to our ask. Now when you go to second graph, we're still in ask, you have to delete the previous answers that you just graphed. Okay, delete everything. So now we're going to start with this table. First of all, DNE means does not exist. It means there's nothing graphed to the left of the asymptote. So 1/25 is 2. 1/5 is 1. 1 is 0, and 5 is -1. 1/25 and 2. 1/5 and 1. 1, 0, 2, 3, 4, 5, -1. So the domain is 0 to infinity, and the range is all real numbers, which is -infinity to infinity. You can write either one. You don't have to write both these, just pick one. But your domain is always the asymptote with a parenthesis to infinity. Make sure you have arrows on both these. Make sure it's curving. Make sure you have at least 3 points. And make sure you have arrows on the ends. So this one, we're not going to do what it says about inverses. We're just graphing. So you have log Your homework is what's on the corner. Can you let me pass those out? Yep.
What did we do yesterday?
Huh?
What did we do yesterday?
Notes, which is up here, I think. There's a notes. I have an answer. I have an answer key up here somewhere to this.
We got Miss Rollins in here. Wrong with that.
I'll get my phone so I can take a picture.
I don't even know where they're at. I'm in the middle of the video. Let me find it.
I've been up since fucking 6 o'clock.
Hey, excuse me, making a video here. Watch the language. I'm in the middle of the video. Not
6 o'clock. No, 6 o'clock. Where's the homework?
Over here.
Round with the wish.
Does anyone have the notes from yesterday that Joel can copy? Because I can't find mine.
Let me get on the video, Miss Rollins.
I got
already on it.
Let me teach the class, Miss Rollins.
Listen, I just do the homework and I'm going to make the video. Okay, so we have alpha window. We have 1/3.
No, we're not going to see it.
Aren't these notes, Miss Rollins?
Does it say notes or does it say homework?
It says worksheet, but still.
Okay, worksheet is notes. I mean homework.
No.
Yesterday, but I'll do it again.
That was yesterday was the notes. This is the homework to see if you can do it. Okay, press second graph. Delete the previous answers, and we're gonna find our own. Oh, this time, you know what? Because they don't give us a t-table of predetermined numbers, anything that has a 3 involved with a 3, like 3, 9, 1, anything that involves a 3, you can punch those in. This time I'm turning my ask off. Second window. I'm going to auto. Press enter. So go second window, go to auto, press enter. Now I'm just going to go to my regular t-table now. Notice all the error signs. I'm kind of high up here. So you basically find the first number past the error signs. Okay, here's some numbers. So it looks like 1, 0 is one of them. 3, -1. And then keep going down until you find another nice number. And there's 9, -2. I think that's a good one. 2, 3, 4, 5, 6, 7, 8, 9, -2. So the points that I just did was 1, 0, 3, -1, and 9, -2. 3 points is all you need. So if you know what a log graph looks like, this one right here, it's going to look like this one because of the fractional base. See how that was 1/5? This is 1/3. So it's going to come down. The asymptote is 0 again. And the reason I know that is because there's no parentheses. If it's just x by itself, the vertical asymptote is the y-axis. So every problem that we've done so far has an x, no parentheses. Which means your domain is the same as the first two, 0 to infinity. And the range is all real numbers. Make sure you have arrows on the ends. Make sure you have at least 3 dots and make sure this is curvy. This last one, this is a 5. Let's just clear this up. Alpha window, 5. Log base 5. X. Graph. I'm using it. Here, you can use this one. Anyone else need a calculator? So C2, do your homework. You guys can use your homework on your quiz tomorrow. If it's not done, you can't though. You can use your notes and your homework, and it's all going to be stapled to the quiz, and you're going to get points for all of it. So let's press second graph. So I see a 1, 0. So there's 1, 1, 0, and I'm going to plot 1, 0. I see a 5, 1. 2, 3, 4, 5, 1. And then the next one, if you kept scrolling, would be like 25 and 2. I don't really want to scroll that long. So if you can think of something else that has to do with a 5, because of the base 5, that number to me is 1/5. It's got a 5 in it. So let's go back to second window. Ask. And ask for 1/5. You see how it's -1? So 1/5 is like right here, -1. And that's 3 points. So all you need is 3 points. So Come down, arrow, arrow. Domain, 0 to infinity. Real numbers. Now the back, the one on the quiz tomorrow is going to say describe how the graph differs from, and then state the domain range. It's also going to say graph both. So this first one, log base 3 of x, when it has a base 3, first of all, if there's no parentheses, the vertical asymptote's there. There's always a point at 1, 0. And when it has a 3, go to 3 and go up 1. It's a little quick graph of that. Okay, that's, you can graph it on the calculator, but that's pretty much what it looks like. So you do not have to do the domain range of this one. The new one, what is the difference of this one and this one? So you would say that's not in the parentheses, so you would say it's down 1. So basically each one of these 2 points I just graphed would be down 1. So instead of 1, 0, it's going to be 1, negative 1. Instead of 3, 1, it's going to be 3, 0. It's going to look very similar to the first one, except both points move down 1. You can graph it on the calculator to see that. But domain, since there's no parentheses, the asymptote did not move. So your domain is 0 to infinity. Range is all real numbers. Now it's when you have parentheses that it makes a difference in the domain. So the first one is a base 2. So no parentheses, so asymptote's here. There's always a point at 1, 0 if there's no parentheses. And because it's out of 2, go over to 2, go up 1. Because if that's a 2 there, the whole answer is 1. Again, you can graph that on the calculator. So what does it look like if you have this? This minus 1 with the x means you're going to go 1 to the right. That means you're moving the entire asymptote 1 to the right. So you have this. Oops, that's wrong. Your asymptote is 1 to the right. So this is your asymptote. So there's usually a point that's right here. So if you pop, so this is 1 right and 2 up. Okay? So usually there's a point at 1, 0, correct? So that point that's usually at 1, 0, we're going to go 1 to the right and 2 up. That's where one of your points are. So it kind of just looks like this. Right? Now, you would need to graph that on your calculator to get 3 points, but you can do that. But the domain is whatever your asymptote is. So anytime you have parentheses, whatever the opposite of this number is, goes here. Domain is 1 to infinity. Range, all real numbers.
Isn't domain always negative, infinity, infinity?
So, yep. So I'm not going to graph any more of these right now, because you can do those on the calculator. But so this one right here to this one, what's the difference? This is the difference. It's in the parentheses, so you're going to go to left, the opposite of that sign, which means your vertical asymptote moves 2 to the left, like this. That's what that means. So your graph's going to look something like this. So since you moved it to the left, the negative 2 goes in your domain. That's your answer. Again, here's your parentheses. This one's going to go 3 right, and then this is going 1 up. But this is what affects your domain. 3 right. So 3 right, 3 to infinity. This is all real numbers. There are no parentheses here. Do you see that? No parentheses. So your domain is 0 to infinity. The vertical asymptote doesn't move. The vertical asymptote is still here. This just went up 3. So instead of having a point at 1, 0, it'd be up 3. But the range is still all real numbers. And this one. You've probably never seen this before, right? Natural log. Natural log, let me show you where that's at. On the calculator, see this LN right here? That's what natural log is. This is your log. This one has a base 10. This one has a base E. See right above it, E to the X? This has a base E. So when you see a natural log, it means base E. But so it's really easy to type in. You just press in this key right here, natural log X. If you graph it, it still looks like the normal ones. It's still got 1, 0 right there. And E is like 2.7. So the next point would be 2.71. Okay? So to type the next one, you would do natural log X plus 2. And all that does is it moves it to the right 2. Or sorry, oh, it looks, I'm sorry. to the left 2. Do you see that on the graph? Moved it to the left 2, the red one. So this is left 2. So left 2 means -2 to infinity, all real numbers.
Left to the right.